Okay, I was just going to do kind of a video to go with these first two examples in the practice in case you were feeling real lost and you weren't at school and you couldn't ask a question. Here is a little thing to help you. So for all of these, we're going to write the balanced chemical equation. We're going to include the energy term either on the left or on the right, and the reactants to the products. We're going to do the transfers down here and then do the standard sketch. Okay, so first equation, you heat sodium hydrogen carbonate. That might help you to know that this is also known as bicarbonate. I can't remember which one it is on your table E or table, whatever table has all of the polyatomics on there, but it's going to be Na, which is +1, HCO3, which is -1, so we just need one of each of those. It's going to decompose or break down into sodium carbonate. Okay, so that's Na, and then carbonate is CO3, but this has a -2 charge, and this has a +1 charge, so we crisscross that, and we end up with Na2, and then CO3 1, but I don't need to write that one. Okay, plus plus water vapor. Okay, we know water is just H2O, and then carbon dioxide, that is a covalent compound, so we just use our prefixes. There's no prefix on carbon, so it must just be 1. Di, and dioxide means 2. So that's CO2. Okay, but we are supposed to put the energy term on there. It says when you heat it. That sounds like I'm adding energy into the system. So I'm going to have energy there. We're adding it in there. We do that. That breaks it down. We do need to balance it quick. It looks like our sodiums are going to need 2. Now, you might need to do the full balancing chart. I'm kind of a little bit past that phase of my life, but I think we've got 2 NAs, 2 H's, 6 oxygens, and I see 1, 2, 3, 4, 5, 6. Okay, we're all balanced up there. Okay, just like basically every time, I'm just going to start with 2 energy bars so I can go up or down on this. I know this is endothermic because I added heat to it, right? I know that because it says so right there. And so I'm just going to add in 1 box of heat into my system. So when it comes in as heat, it is going to get added into the thermal energy account. So we'll add that baby right on there, and then we still have the same chemical energy. But in order for it to actually impact the system and cause this reaction to occur, we gotta add some energy in here to break some bonds. And so we're gonna transfer that all over there. I'm just gonna make a little note for you that we got some new bonds happening there when that transfer happens. No energy is coming in or out of the system at this point. It's just transferring in between or within the system. So we don't have to write anything there. And so then after some time has gone by, we're going to have that reaction come to completion, so our thermal energy will go back down to where it was, and this one now has added energy to it that came into our system as heat. So our products have more energy than our reactants, which is not surprising because this is an endothermic reaction, right? We had energy at the start. So then the last thing we were supposed to do, we did step 2, we did step 1, is do the standard potential energy thing. That's just like this little guy, like this, where you've got energy over here, and then reaction progress over there. Reactants for lower energy, we added energy in, and we ended up at our products. So that would be an example. And basically all of the ones that are endothermic are going to be pretty darn similar to that. Oops, I just wrote on the next one. Okay, I'll do the next one in a separate video.